So in this example, ladies and gentlemen, the main important thing I wanted you guys to take away from this is whenever we're adding and subtracting, Jazeel, when we're adding and subtracting, we can only add or subtract when our radicands are exactly the same. So in this problem, you guys can see that our radicands are not the same. When we multiply or divide, we can multiply them with them being different. But when we're adding or subtracting, they have to be exactly the same. So therefore, what we need to do is now simplify them so that they are exactly the same. So I'm taking the cube root. Cube root is looking at what number multiplied by itself 3 times. Ladies and gentlemen, we can do the factor tree for 54 and for 16. But guys, it takes a while. So I'm trying to move us past that. However, if you're still at that stage and you need to use the factor tree, then by all means use it. But what I'm going to do is I'm going to rewrite 54 as 27 times 2 and then x cubed minus the cube root of 8 times 2 x cubed. The reason why I rewrote these answers, or these values, the radicands, as this, is because I can take the cube root of 27. 3 times 3 times 3 is 27. So when I do my prime factorization, 3 times 3 times 3 is 27. Remember the cube root is saying what number multiplied by itself 3 times. So the cube root of 27 is 3. The cube root of x cubed is, x. What's left over is the cube root of 2 minus. I broke down 16 as the 8 times 2. Why? Because 2 times 2 times 2 is 8. So the cube root of 8 is just 2. The cube root of x cubed is x. So minus cube root of 2. So now what you guys see here is now I'm subtracting 2 terms where the radicands are exactly the same. So you guys see how this is a cube root of 2 and cube root of 2? So it's just like now, just like if I was going to say, 8 apples minus 2 apples would be 6 apples, right? 3x times 3 cube root of 2, or times the cube root of 2 minus 2x cube root of 2. I just subtract my front terms, which is just x cube root of 2. Because 3x minus 2x is 1x, or just x. Did everybody see that? And my radicands just remain the same. We don't actually subtract the terms in the radicands. That's not like multiplying and dividing. Multiplying and dividing where we did that, but in